Hello everyone, welcome to my channel, and this channel is for educational purposes. We generally try to look at uh, latest and greatest theories of everything and paradigm shifting research, usually done long ago and by people who you've never heard of or haven't heard of enough. And today is video number 341 on Dewey B. Larson and his reciprocal system of theory. And Mr. Larson's theory was called the reciprocal system. In it, he posited that we live in a universe that is made out of motion. And motion for Larson was the relationship between space and time that yields a generalized reciprocal relationship between space and time, hence the name the reciprocal system. And you can think of space and time, neither one of them has an independent existence. They only exist together in motion. And they both have 3 dimensions. They both have, that's what Larson calls coordinate space and coordinate time. They both have a scalar component, meaning that they possess a motion that has no specific direction. But it does have a magnitude. You would model that using, or you could model that using a balloon with dots on it. As you blow up the balloon, all the dots are moving away from each other, but in no specific direction. The direction doesn't arise until you assign a reference point. Once you decide that one of the dots is motionless, then you can determine directions. So the directions are related to the reference point, not to the motion itself. Another way of modeling this, if you want to add an extra dimension in the interior, would be just like your raisin bread in the oven. As you heat the bread and it rises, all of the raisins are going to be moving away from each other, but again, in no specific direction. This is also what Larson calls clock time and clock space. The clock is always getting later and later and later, but it's not moving in any specific direction. And then clock space is, a motion in time outward. Everything is always getting farther and farther and farther apart, which was actually observed by the Hubble telescope that determined that all of the distant galaxies are moving away from each other. And unless we are willing to say that our galaxy is at the center, then that would also mean that our galaxy is participating in that motion as well, away from all other galaxies. Then time and space also have their discrete unit aspect, meaning that time and space only come in discrete units, quantized. There is a minimum unit of time and a minimum unit of space. If you don't have a full unit, then you don't have anything. And if you have 1 unit of space in 1 unit of time, then you have the speed of light. Speed is space over time. The car is moving 20 miles per hour. 20 miles of space in 1 hour of time. But if you have 1 unit of space in 1 unit of time, you have the speed of light, which is what Larson calls unit speed. 1 over 1 equals 1. And this unit speed for Larson is really like the background of the universe, or the null point, the 0 point, the origin, the ether, reference point of this universe. So half of the universe is moving faster than the speed of light, and half is moving slower. You can think of this in terms of reciprocal. If you when you have a reciprocal, this is implying a multiplicative relationship. The kind of pairs of opposite of reciprocals, they multiply to 1. Whereas in legacy science, they're using an additive system where the opposites they add to 0. So in a legacy system, they're measuring from 0, from stationary, and it could be +1, +2, +3, +4. And then on the negative end, it would be -1, -2, -3, -4. But with a reciprocal system, you have 1 in the center, not 0. 1 unit speed, the speed of light, is at the center. And then on one side of opposites, you would have 2, 3, 4, and 5. And on the other side, you would have 1/2, 1/3, 1/4, and 1/5. So the two opposites, when they come together, they multiply to make 1, as opposed to adding to make 0. So this is a kind of a higher power of a system. It's multiplicative as opposed to additive. And so Larson basically put together that first postulate. That's his first fundamental postulate. His second fundamental postulate is basically that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. And there is some dispute about that particular postulate that we will get into here very shortly. But those two postulates he started with, and he basically said, well, if the universe operates according to those principles, then what does this universe look like? What is my theoretical universe composed of? And so he went through a process of deduction to figure that out. If you want to look at my old videos, go back about 9 months or 10 months, and you'll see that I did about 15 videos called The Outline of the Deductive Development of the Reciprocal System. This is where Larson goes through really like 165 steps of his reasoning process to get from his fundamental postulates to a theoretical universe. Then with his books, he basically compared his theoretical universe with the legacy scientists' view of the universe. And usually they come up with the same results in terms of all the Newtonian questions. He really just kind of affirms Newton's laws, except that he provides the concepts also behind those equations. And then in the relativistic areas of the very small, the very large, and the very, small, large, and fast, they diverge from Newtonian mechanics in the same way that Einstein's do. But again, he comes up with better results than Einstein because he provides the concepts and that underlie the math. Even when Einstein has the math right, he doesn't have the concepts right, and in many cases he doesn't have the math right either. He often is just borrowing the math from people like Minkowski and Lorentz, so Larson is entirely an improvement as far as getting results. And so people can, often say that, oh, this doesn't make any sense. I don't get the space and time, at reciprocals of each other. But Larson is able to produce results, and that's he was able to derive many of the basic properties of matter strictly from theory. He can tell you, he has equations that can tell you what the boiling point of nitrogen is, or what the, freezing point, or the specific heat, or the, the compressibility of every one of the atoms in the periodic table, as well as many compounds as well. And he also was able to make a lot of predictions of things that hadn't even been discovered yet, such as the existence of quasars and their qualities. Larson was able to predict the existence of quasars several years before they were actually discovered. So, he's able to produce results. Sometimes you're not really able to discern all of the steps of his deductions unless you really understand the theory quite well. And so that's kind of where I am. I'm starting to understand the theory a lot better, even though I've been studying it for over 20 years. And some of it's starting to make sense where it didn't before. But you just have to kind of grind away at it, because it's very unfamiliar concepts, and you have to unlearn a lot of the science that you learned beforehand, which is one of the mistakes that Larson made, is he kind of targeted his theory toward the scientist, and he probably should have targeted toward the layperson, because the layperson would have been more receptive to it. The scientists rejected it out of hand in general. There's very few scientists who are open-minded enough to kind of admit that they don't know what they're talking about, and that this other person has an angle that is fruitful. So, and that's historically, documented by Thomas Kuhn in his Structures of the Scientific Revolution, which came out about the same time that Larson was making many of his findings in the early 1960s. Okay, now what we're doing today, apologies for yesterday's video. I just had to shut it down because my phone just shut off after I got that Amber Alert. So we're going to take over here in part 3 of this article that was written by Dr. Bruce Peret, who is one of Larson's chief revisers and followers and revisers, meaning that he follows the spirit of Larson's work, but he did correct a number of Larson's mistakes. Larson contended that his theory was correct, but whether he applied it correctly in all situations was dubious, and that he was sure that he made some errors, and that he would look forward to people coming along and correcting those over time. And I think that's what Dr. Bruce Peret has done, along with Dr. KBK Nehru. They came up with something that's called RS2, the reciprocal system 2, the re-evaluation of the reciprocal system. And we're looking at one of his kind of primers of the reciprocal system 2, called RS2-101. And again, if you want to go back to the start, go back 2 episodes and you'll get the start. Now, he was actually going over the postulates. In this article, he kind of compares, it's called Creating a Theory, and he compares 2 different approaches. One is the natural approach, where you're looking at nature. Nature can be determined, the natural law can be determined through observation of how the natural law operates. That is one way of creating a theory, and the other is through an artificial process, which is determined by commandments, how you want the universe to operate. And so he's making various delineations based on whether this is an observation or is this a commandment. And he really is determining that the first postulate, the universe is made out of motion, and motion comes in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. That is an observation, and therefore natural law. Whereas the second postulate is a commandment that is artificial. So Peret does reject a lot of the second postulate, especially the part about the Euclidean geometry. Okay, let's start with his writing right here. His second postulate is commandment on the way things behave in his artificial reality, man's law. The physical, this is, he's quoting then Larson here, the physical universe conforms to the laws of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Here, Larson includes other artificial realities, that of the commutative subset of consensus mathematics, and the consensus reality created by Euclid regarding geometry. If you notice, there are no observations here. Larson is laying down the law on how to interpret his artificial reality, a commandment. The primary magnitude clause is borrowed from Newton's observation that, quote, any object in motion tends to stay in motion unless acted upon by a force. Combining Newton's observation with his own observation of speed as the sole component of the universe, a constant magnitude of speed was required in order for the system to work. If speed varied, then the elements of the periodic table would bounce around, changing from one element to another as the speeds changed. This did not match observation. Iron stays iron and doesn't suddenly become aluminum. So the underlying magnitude, the primary one defining the structure, must be absolute. Okay, this section is called The Beginning. This paper focused upon the basic nature of reality and how we create the world we choose to live in. It shows how Dewey B. Larson used the concepts of observation, natural law, and from that created an artificial reality that responds to his rules, man's law. Set to paper to create a theory known as the reciprocal system of physical theory. Larson's theory has never gained consensus status except as a conscious act between a few individuals. Even then, there are still many disagreements over the interpretation of Larson's theory. Because those involved do not have the same premises that Larson did while developing his artificial reality. In 1996, Professor K.V.K. Nehru of India and Dr. Bruce Peret of these United States of America started a reevaluation of Larson's work in hopes to clarify some of the contended points, which led to a second attempt to define a universe of motion, an improved artificial reality called RS2 that is on its way to theory status with these papers. Okay, that wraps it up with that paper. So I was a lot closer to the end than I originally thought. Let me just read one of these footnotes here. Originally, Larson referred to motion as space-time, but that led to confusion with conventional theory as well as his own use of time-space to represent the region of extension space. Okay, so I think he goes through this in the second paper a little bit more in detail. But in Larson's first postulate, originally, uh, he said the universe is made out of space-time, which was in discrete units and in 3 dimensions, and space and time were reciprocally related. But after a fashion, I think really almost 20 years, he changed the space-time in the postulate to motion. Eventually, toward the end of his life, he actually used the term change in 3 dimensions. So he went from space-time to motion to just change in 3 dimensions. So that shows a little bit of Larson evolution of his thinking, or maybe just of his ability to kind of communicate his concepts. I'm not sure that he changed space-time just because it wasn't the word he was looking for, but more that it didn't, it didn't translate to people as well as maybe motion did, and then eventually change in 3 dimensions. Okay, now just toward the end here, I'd like to just give you an overview of where we're headed. Tomorrow, we're going to start Peret's second primer paper here called RS2-102. And this is on his fundamental postulates. So we're going to be going over kind of the history of Larson's fundamental postulates in this paper, and how, an extension of what we just talked about, how his postulates evolved over time, and then Peret will weigh in with his contribution about what's wrong with the postulates and how he would change them in his theory. And then we also get into Larson's metaphysical postulates, because the fundamental postulates of the reciprocal system only define a physical theory, but there is in observation there are things that go beyond the physical, and such as life and related phenomena, where the physical generally abides by the law of entropy. Things become more and more chaotic. Life operates in the opposite direction, where things become more and more organized. And so he has a separate set of postulates for what he calls metaphysical postulates. And so we'll be going into that in the second paper. I believe Peret has 9 of these primers on RS2, introduction to RS2. So we'll learn those in the next couple weeks. And I think after that, we're going to end up going into Larson's book on economics. He has 2 books on economics coming from the same general postulates. And how he applies it to economics is pretty interesting. He's got 2 books on economics. We'll probably just look at one of them, which is called The Road to Permanent Prosperity. And so if you want to get rich, you just continue to listen to this. And the other one is called The Road to Full Employment. And then we're going to try to get into one of Larson's works on chemistry that is called Basic Properties of Matter, which I alluded to earlier, where he takes many of the basic properties of matter and he derives them strictly from theory, and then compares his results to the tables, scientific tables, and so on. It's a very interesting study, even though it's a little bit, certainly a little bit over my head as far as delving into matters of chemistry and also into very abstract theory in some cases. But I think it's still very instructive. And that's how you just have to take Larson's work and the reciprocal system in general, is that sometimes you're going to get lost. Sometimes you're not going to be able to figure out what's going on or what he's talking about. You just have to deal with it. You just have to keep moving forward, and save your criticisms for after you've done reading. Don't just put it down because he says something that disagrees with something that you already know to be true. Just suspend disbelief long enough to hear him out, and then you can criticize him after you've heard his whole statement. But the thing is that usually you're not able to really have a good angle to criticize Larson until you've read several of his books, because sometimes it appears as if Larson is just pulling things out of his hat. Like, just where is he getting this from? But then you see that he's applying it consistently in all fields. He's using the same rules to apply to the atom as he is to the galaxy. And so, but you can't really see that until you've had a certain depth of understanding of Larson's work. So that's why I'm trying to be very thorough in going through many different aspects of Larson's work to see that he's covering these consistently. And even though I've done 341 videos now on this, I still haven't even, scratched the surface on a number of important things that Larson uses, such as the interregional ratio. I think I scratched the surface, but barely on that. And also his, kind of how he came up with the periodic table, how he's using different, the quantization of motion, and that he uses that consistently, and the mathematical differences between space and equivalent space, and many other kind of things that he uses in multiple books, but you don't really, it's difficult to tell that unless you've read multiple books. If you just think he's using it for one thing, you're just kind of like, oh, he's just making this up so he gets the right answers. But then he uses it for another thing and he gets the right answers for that too. So we will look into all that in the next time period going forward. Thanks for tuning in today, and I hope to see you tomorrow. Have a great day.